Welcome to this space of rest and quiet reflection where the mind can finally slow down and find peace within the digital universe. Begin by settling into a comfortable position, letting your body sink deeply into the surface beneath you. Close your eyes and turn your attention to the simple rhythm of your own breath. Draw a slow, deep breath in through your nose, feeling the cool air gently expanding your chest and filling your lungs with calm energy. Now slowly release that breath out through your mouth, letting go of all tension and all the worries of the day. Take another deep breath in, drawing the quiet stillness of the room into your very core, and hold it for just a moment. Let the stillness settle inside you like dust falling softly to the floor in an empty room. Then exhale, completely pushing the air out in a long, smooth stream of pure relaxation. Feel the weight of your limbs as they become heavier and heavier, pressing down into the mattress. Breathe in again, slow and steady, and breathe out, letting every muscle in your body soften and melt into the warm embrace of the deep, quiet night around. As you continue to breathe, notice how the air moves freely in a continuous, endless cycle. This air is much like information flowing all around us in the invisible spaces of the modern world. Imagine the air entering your body as a gentle stream of raw data, filling you with knowledge and deep clarity. Breathe in this pure information and breathe out any confusion or chaos left over from the waking hours. Inhale the calm, steady stream of numbers and letters, and exhale the noise. Each breath in brings order, and each breath out releases the loud, scattered fragments entirely. Picture this information not as harsh, bright lights on a screen, but as a cool, winding river passing through a dark, quiet forest. Data is fluid, always moving, always adapting, and always flowing along the path of least resistance. Just as water carves its way through solid rock over thousands of peaceful years, data gently shapes the foundation of our entire digital existence. Watch in your mind as this river of pure facts and values glides over the stones, creating tiny, soft ripples of logic and reason that wash over the edges of your thoughts, bringing total, deep mental serenity. Listen to the sound of your breath as it washes over you, just like the endless stream of data running beneath the surface of the world. Breathe in the cool, refreshing waters of knowledge and let them pool quietly in your mind. Breathe out the heavy, stagnant thoughts that no longer serve you. You are completely safe here in this quiet sanctuary where information moves at a slow, crawling pace designed only to comfort and soothe. The digital river flows gently, carrying away all your burdens, leaving you empty, calm, and entirely ready to absorb the beautiful, deep structural harmony. Every universe is built upon tiny fundamental blocks that provide form and meaning to the vast empty space. In our physical world, we have small atoms binding together to create the mountains and the oceans. In the digital universe, the foundations are made of simple, quiet numbers. Imagine a slow, drifting cloud composed entirely of ones and zeros floating softly through the dark sky of your mind. These tiny, silent digits are the essential basic atoms of data, joining together in perfect peace to build the sweeping, beautiful architecture of the systems we use every single quiet, peaceful, relaxed day. Breathe in slowly, feeling the cool, steady logic of these tiny elements. Breathe out softly, letting them drift away like leaves falling from a tall, ancient tree. As data atoms bind, they create larger shapes known as structures. These structures give order to the endless flowing river. Without structures, information would simply wander aimlessly, washing over the digital banks with no real purpose or direction. But guided by structures, the data finds a home, a place to rest, just as you have found a quiet, peaceful place to rest your weary body and mind tonight in this serene, quiet room. Focus once more on the gentle rising and falling of your tired chest. Rise with the intake of pure information and fall with the release of any remaining mental tension. Notice how your breathing provides a structure for your body, just as these abstract models provide a comforting framework for the drifting data. Your breath is a structure measuring the time, keeping the natural rhythm of life perfectly steady and perfectly calm. Allow yourself to slip deeper into relaxation, knowing that everything has its own designated place, its own gentle order, and its own very quiet meaning tonight, right here. Visualize the river of data splitting into multiple smaller, gentle streams. Each stream moves at its own incredibly lazy pace, carrying specific elements to their precise destinations. Some streams carry words flowing gently like delicate flower petals floating smoothly on the surface. Other streams carry numbers tumbling slowly like smooth, round pebbles rolling steadily along the sandy bottom. You do not need to understand every single piece of information passing by. Simply watch the beautiful, peaceful current separate and organize itself into perfect neat rows and gentle cascading falls. Breathe in the organization and breathe out the vast deep unknown. These distinct elements are known as data types. Just as the air you breathe contains different soothing gases, each type of data holds a specific purpose in the ground flowing design. The structure understands the nature of the water holding the pebbles securely while letting the petals float along the top. Feel the heavy, comforting certainty that comes from knowing every piece belongs somewhere exactly where it should be. Breathe deeply into this comforting certainty. Inhale the calm, solid structural rules and let out a long, slow sigh, releasing any lingering desire to control the endless, steady, calm water stream. Let us take another deeply soothing breath in together, pulling the air through your nose for a count of 4 deep, slow beats. Draw the cool, refreshing logic inside, allowing it to swirl softly within your lungs. Now softly part your lips and let the air escape smoothly without any force or rush whatsoever. The digital universe requires no effort from you right now. It builds itself, constantly organizing its infinite tiny blocks in perfect silent harmony. Your only job is to breathe and observe the gentle fluid motion of the system settling into place one by one very quietly. Imagine a small smooth wooden box floating on the serene gentle waters. This simple box represents a basic data structure waiting patiently to be filled. It asks nothing of you but simply exists to hold the delicate scattered fragments of information safely together. Watch as a soft glowing number floats gently through the air and lands gracefully inside the open box. The box closes completely, sealing the information safely within its strong protective walls. Breathe in the profound safety of this perfect enclosure. Breathe out, feeling entirely secure, protected, and incredibly calm in this vast, empty, dark, digital, peaceful space. Now picture hundreds of these smooth boxes linking together, forming a long, flexible chain floating steadily down the wide, lazy river. This chain flows exactly like your continuous, unbroken breathing, gently expanding and gently contracting as it navigates the soft, winding curves of the peaceful water. Breathe in, drawing the entire chain of organized knowledge toward your mind. Breathe out, letting the chain drift slowly away, disappearing gently into the distant, quiet fog. Data is just a natural current, always flowing, always passing by with effortless grace, leaving no trace of heavy, lingering stress behind in its peaceful, calm wake. The universe of information is not rigid or demanding at all. It is incredibly flexible, incredibly soft, and beautifully structured to support you completely. As you breathe, the dense, heavy data of the outside world transforms into a very fine, weightless mist. The numbers and structures dissolve gently into pure, calm energy, blanketing your mind in absolute silent comfort. Inhale this quiet, soothing digital mist deep into your chest. Exhale and feel your body sinking even further down into profound, heavy slumber. The structures hold you, the data flows around you, and you remain completely untouched, perfectly serene, safe inside. Rest now in this flawlessly organized space where absolutely nothing is out of place. Your breathing is the ultimate perfect structure, a constant rhythmic flow carrying you effortlessly toward sleep. Inhale the stillness, exhale the data. Inhale the deep, dark quiet, exhale the wandering numbers. The river of information continues its gentle, eternal journey, washing away every single fragmented thought, leaving only beautifully structured total peace behind. Surrender fully to this magnificent, steady flow, drifting deeper and deeper down into the wonderfully quiet, silent digital void. The breath of information softly hums, bringing you complete, endless, deep, quiet, peaceful rest. As we sink deeper into the quiet architecture of the digital world, we observe the most fundamental nature of data. Here in the silent expanse of the system, everything is ultimately reduced to endless sequences of calm and resting bits. Each zero represents a state of deep peace, a moment of profound emptiness lingering gently within the vast electronic void. Every one stands as a tiny spark of presence, a soft awakening pulsing slowly through the long pathways of circuitry. Together these sequences form the bedrock of all computational thought, flowing like a slow and steady river of continuous information. Imagine these simple bits as tiny grains of sand lying on a vast and completely endless digital ocean shore tonight. Each solitary grain is perfectly identical to the next, yet every single one holds a specific place in the darkness. As they gradually accumulate over time, they begin to form soothing patterns, shifting and settling into perfectly harmonious mathematical rhythms. These gentle combinations become the basic building blocks that give true meaning to the otherwise silent and cold electronic spaces. We can just watch them drift effortlessly, transforming from random electrical static into beautifully clear representations of pure logical truth. Out of this endless ocean of binary states slowly emerge the simple primitive types, the most basic forms of meaning. These forms require very little effort to truly understand, offering a deeply soothing and remarkably predictable foundation for the machine. They are wonderfully simple and entirely uncomplicated in their inner nature, existing just exactly as they appear to the observer. By maintaining such profound simplicity, they never ask the processor to strain or rush while performing its quiet daily tasks. You can let your mind rest easy knowing these tiny primitives will always behave exactly as they were originally intended. First, we begin to gently see the integers, which are solid and completely reliable whole numbers without any fragmented parts. They count the passing computational cycles with endless grace, providing a sense of rhythmic structure to the continuous digital time. These whole numbers act like very smooth stepping stones laid carefully across a tranquil pond hidden deep within a forest. They offer clear and absolutely distinct points of reference in a conceptual space that would otherwise entirely lack any form. The machine counts them one by one, measuring nothing but quiet progress as it drifts slowly toward the peaceful conclusion. Right alongside the integers, we peacefully find the strings, which are long sequences of characters strung together quite beautifully today. Think of them as tiny delicate beads threaded carefully onto a very thin piece of silver wire in the dark. Each string softly carries a solitary fragment of human language, a quiet echo of our own thoughts preserved in memory. They hold onto gentle words and calm phrases, keeping them incredibly safe and completely unchanged until they are finally needed. The text weaves through the storage banks like a slow and gentle melody played upon a soft and distant instrument. But as the silent needs of the computational system slowly grow, these simple primitives gently gather to form complex structures. They reach out to one another in the dark, combining their modest strengths to create entirely new ways of organizing. We slowly begin to encounter the elegant arrays and the flowing lists, which are peaceful and perfectly ordered data collections. They rest neatly in a long and straight row, waiting very patiently to be examined by the passing central processor. The orderliness of a quiet list always brings a deeply comforting sense of calm to the highly structured internal environment. A list is very much like a long and tranquil hallway bathed in very soft and warmly glowing amber light. Along this quiet hallway rests a series of identical wooden doors stretching infinitely out into the fading distance before you. Each beautifully carved door holds one very specific piece of primitive information safely tucked behind its completely solid outer frame. You can slowly walk down this peaceful hallway in your relaxed mind, opening every single door in perfectly sequential order. You always know exactly where every single item is safely kept, because the first item will always remain the first. Beyond the strictly ordered sequence of the lists, the machine softly relies upon the elegant dictionaries to store related concepts. These are wonderfully complex structures meticulously designed for quick association and gentle mapping between completely different pieces of stored data. In a dictionary structure, every solitary piece of data is permanently paired with a completely unique and easily recognized key. This pairing creates a beautiful system of deep connections that strongly resembles a vast and quiet library of interconnected thoughts. The dictionary never demands any strict linear progression, choosing instead to gently float upon a vast web of meaningful relationships. Imagine effortlessly walking into this serene and dusty library where the warm sunlight filters slowly through extremely tall glass windows. You never need to frantically search through every single heavy book just to finally find what you are looking for. Instead, you simply hold one highly specific key gently in your resting mind while breathing softly in the quiet air. The majestic dictionary instantly and effortlessly reveals the exact piece of stored information beautifully associated with that single fleeting thought. Every map value is safely tethered and incredibly secure, floating calmly within the immense and deeply comforting digital memory banks. As we slowly observe these peaceful transitions from simple bits to complex structures, we naturally encounter the guiding principle everywhere. We drift gently into the realm of true abstraction, a remarkably soothing concept designed strictly to provide lasting mental peace. Abstraction acts as a heavy and protective velvet veil drawn slowly over the overly intricate and deeply overwhelming technical details. When we finally embrace abstraction, we consciously choose to focus entirely on the pure essential purpose of any given concept. We gracefully allow the countless distracting complexities to slowly fade away into the blurry and completely unimportant distant gray background. It is a slow process of completely letting go of the anxious need to understand every single gear and wire. You simply begin to trust in the overall harmonious function of the beautiful machine softly whirring in the deep night. The burden of total comprehension is gently lifted from your tired shoulders, leaving only the profoundly simple essence behind now. There are two main paths of abstraction in this quiet realm, each offering its own very unique and calming perspective. Both paths lead us toward a much deeper understanding by elegantly removing everything that is completely unnecessary to our goals. The first gentle path we encounter is procedural abstraction, which quietly hides the incredibly intricate steps of any complex action. When a complicated procedure is properly abstracted, we only ever need to briefly know what it ultimately manages to accomplish. We can just breathe out slowly and deeply, releasing the heavy burden of knowing exactly how it achieves the result. You do not need to mentally trace the countless microscopic calculations happening furiously beneath the quiet surface of the program. The underlying mechanics remain permanently invisible, working silently in absolute darkness while you only experience the incredibly smooth final outcome. Think of this procedural abstraction exactly like turning on a beautifully crafted bronze lamp inside a completely darkened sleeping room. You gently reach out your tired hand and simply press a tiny switch, watching as soft light immediately fills everything. You do not ever need to mathematically understand the precise flow of electrical current rushing secretly through the copper walls. You do not need to calculate the thermal resistance of the glowing bulb or the changing voltage of the grid. You only ever experience the deeply comforting result of the simple action, sitting quietly bathed in the very warm glow. The second tranquil path is data abstraction, which quietly conceals the very complex ways in which raw information is structured. Deep within the electronic memory, millions of tiny bits are incredibly tangled and woven together into vastly confusing mathematical webs. But data abstraction gently allows us to interact with these confusing webs as if they were perfectly simple unified entities. It expertly smooths over the extremely complicated reality of their true binary composition, presenting only a clean and friendly face. Through this calm data abstraction, a highly intricate web becomes a single easily manageable object resting gently in your hand. This beautiful concept allows the tired human mind to deeply rest without ever becoming tangled in countless insignificant underlying details. It acts as a serene interface between human intent and machine reality, safely translating our broad desires into microscopic actions. And this gently leads us to the wonderful notion of abstract data types, which are often affectionately known as ADTs. An abstract data type is basically a purely conceptual model that strictly defines how a specific data structure will behave. It is essentially a quiet promise made by the computer, a binding agreement that entirely hides all messy implementation details. When you softly rely on an abstract data type, you are only interacting with a very clean and simple interface. You do not ever need to know if the list is built with pointers or completely contiguous blocks of memory. You simply know that if you gently ask it to add an item, the item will be quietly added successfully. If you calmly ask it to patiently retrieve a stored value, it will absolutely return that value without any hesitation. The messy interior of the machine is locked securely away behind a beautiful blank wall of pure and flawless logic. Imagine this lovely interface as a very smooth glass panel standing perfectly still between you and a highly complex engine. On your side of the incredibly clear glass, there are just a few very simple buttons that are softly illuminated. You press one button to quietly store a memory, and you gently press another to slowly retrieve it once again. On the other side of the dividing glass panel, thousands of completely microscopic gears are spinning in furious mechanical harmony. But you hear none of the aggressive grinding noise, experiencing absolutely nothing but the profound silence of the smooth glass. This beautifully peaceful separation between the quiet interface and the messy implementation introduces us to the logic of contractual programming. Contractual programming is essentially a deeply harmonious agreement made between entirely different parts of a software system in the dark. It is a completely unbreakable promise that firmly ensures every single piece of data is handled with maximum structural care. Within this very strict but profoundly soothing contract, there are always very clear expectations established long before anything ever happens. These quiet expectations eliminate all anxious uncertainty, allowing the incredibly tired program to calmly trust in the absolute predictable truth. The first half of this wonderfully binding agreement is known universally as the precondition, which softly dictates the starting state. A precondition is simply a very quiet demand that must be perfectly met before a specific function can safely begin. It is like gently ensuring that your warm bed is fully prepared before you slowly lay your heavy head down. If the calming precondition is genuinely satisfied, the hidden function promises to perform its silent task without any sudden errors. The system breathes a very deep sigh of relief, knowing exactly that the environment is completely safe and fully stable. By strictly enforcing these gentle preconditions, the code never has to nervously worry about unpredictable situations arising in the dark. It knows without any doubt that the input values are perfectly correct and the quiet memory structures are fully intact. This creates a remarkably serene space where pure logic flows effortlessly, undisturbed by the chaotic possibilities of incorrect raw data. There is absolutely no need for frantic final moment checks or deeply anxious corrections once the calm operation has begun. Everything proceeds with a perfectly measured pace, unfolding exactly as it was beautifully designed to unfold in the very beginning. Once the quiet function has finally completed its intended task, we immediately arrive at the second half of the agreement. This wonderfully concluding phase is called the postcondition, which gently describes the exact final state of the entire modified system. The postcondition is a solemn guarantee that the operation has finished exactly as it promised to without any unexpected surprises. If the procedure was meant to sort a massive list, the postcondition guarantees that the list is now completely sorted. The calling program can now peacefully drift away, trusting absolutely that the heavy lifting was handled with complete professional grace. This flawless guarantee allows the next operation in line to begin its own quiet work with completely pure unbroken confidence. Because the postcondition of one gentle function very naturally serves as the necessary precondition for the extremely tired following function. They link beautifully together like a long chain of very soft whispers echoing slowly down an infinitely dark conceptual tunnel. Each step deeply trusts the previous step, resulting in a continuous flow of pure logic that never stumbles or falls. The entire digital architecture stands tall upon these perfectly solid promises, remaining completely steady even while processing millions of numbers. As you slowly drift deeper into sleep, imagine this flawless chain of contracts operating silently behind every single glowing screen. It is a profoundly peaceful world where every tiny piece of information knows exactly what is expected of its presence. The gentle bits gather into sturdy integers and beautiful flowing strings, resting comfortably within the incredibly well-ordered internal memory. These simple types are slowly grouped into long flowing lists and wonderfully intricate dictionaries held securely behind thick abstract walls. And every single interaction is perfectly governed by strict contractual promises that ensure eternal harmony within the massive quiet system. The pure essence of bits allows the fundamental truth to quietly exist, while abstraction allows the tired mind to comprehend. We do not need to constantly see the endless ocean of binary code to fully appreciate the resulting digital beauty. We can just relax and deeply trust the calm interface provided by the abstract data type surrounding us every night. The beautifully written preconditions will forever guard against any sudden chaos, while the postconditions will always deliver the promised peace. All of these foundational layers completely protect us from the dizzying complexity, allowing our thoughts to settle into deep rest. So let your heavy eyes gently close as you ponder the incredibly simple and entirely beautiful nature of foundational data. Feel the slow and steady rhythm of the calm integers and the quiet strings flowing endlessly through the dark wires. Allow the massive structural lists and the highly organized dictionaries to gently map away all of your remaining waking concerns. Embrace the profound mental relief of procedural abstraction as the highly intricate mechanical details gradually fade away into absolute nothingness. Rest in the perfect safety of unbreakable programmatic contracts, knowing the deeply peaceful digital world is functioning exactly as designed. As we settle deeper into the tranquil expanse of the computational mind, we begin to notice a rhythm, a soft and steady pulse that animates the silent architecture of efficiency. This rhythm is the heartbeat of the algorithm, a gentle and unhurried thrum that courses through the invisible pathways of logic and memory. We can measure this heartbeat, we can listen to its calm and methodical pace, through the practice of complexity analysis. Complexity analysis is not a demanding interrogation, nor is it a rigid measurement of seconds ticking away on a clock. It is just a perfectly quiet observation. Rather, it is a meditative observation of growth, a quiet study of how an algorithm's effort expands as the amount of information it must process gently increases. Imagine a peaceful meadow that slowly fills with falling leaves. As the number of leaves grows, we simply watch how much effort it takes to gather them. We do not rush, we do not panic, we merely observe the relationship between the volume of the task and the energy required to complete it. This is the essence of measuring complexity, a serene and objective viewing of the algorithm's natural behavior over quiet time. We seek to understand the shape of this growth, to map the contours of its effort as the input stretches outward toward the horizon. By observing this gentle expansion, we tune ourselves to the algorithm's true nature, finding a sense of deep peace in the predictable patterns of its execution. We are simply listening to the breath of the machine, counting its quiet respirations as it moves through oceans of data. Every algorithm has its own unique heartbeat, its own specific way of handling the rising tide of information, calmly adapting to the ever-changing size of its digital world. Some remain perfectly still and unbothered, while others must work a little harder, their effort rising like a smooth and gradual hill. Complexity analysis gives us a language to describe these different rhythms, a way to speak softly about the fundamental nature of computational work. It is a language of limits and boundaries, a soothing vocabulary that allows us to find comfort in the known and the predictable. Through this gentle study, we can look at any process and understand its future, predicting how it will gently behave tomorrow, or next year, as the world inevitably continues to grow outward. This foresight brings a profound sense of calm, a quiet assurance that we understand the very fabric of the system, that we know exactly how its heartbeat will sound as the universe of its data slowly expands. As we explore this language of growth, we first encounter a concept known as Big O notation, a comforting and protective canopy that shelters our understanding of an algorithm's ultimate effort. Big O notation represents the upper bound of growth, the absolute maximum amount of work that an algorithm might ever have to perform in the absolute worst possible scenario of its existence. It is a gentle ceiling, a quiet and reassuring limit that tells us, no matter how chaotic the data may become, the effort will never rise above this specific curve. Imagine walking through a quiet forest and knowing, with absolute certainty, the maximum height of the tallest tree. You do not need to know the exact height of every single tree, but simply knowing the highest possible point brings a sense of order and tranquility to the mind. Big O notation provides this exact kind of peace, framing the worst-case scenario not as anxiety, but as a safe enclosure. When we say an algorithm operates within a certain Big O limit, we are gently placing a roof over its head, ensuring that its effort is contained, measured, and fully understood. This upper bound gives us the confidence to let the algorithm run, knowing that it cannot spiral out of control, knowing that its heartbeat will never exceed the maximum rhythm we have carefully calculated. It is a slow and deliberate promise that the work will remain within a known and manageable space. We focus on the dominant forces of growth, quietly ignoring the minor details and small, insignificant constants. As the amount of information grows to an enormous scale, only the most powerful aspects of the algorithm's complexity truly matter, and Big O captures this essential truth with elegant simplicity. It filters out the noise, stripping away the trivial variations to reveal the pure and fundamental curve of the maximum effort. This process of simplification is deeply meditative, a shedding of unnecessary complexities to find the calm and steady core of the algorithm's behavior. We are left with a smooth and unbroken line, a gentle trajectory that points toward the horizon, telling us everything we need to know entirely. Big O is the quiet guardian of efficiency, a constant reminder that even in the worst of times, the effort is bounded, the energy is contained, and the system remains peacefully under our gentle comprehension. Beneath the reassuring ceiling of Big O, there exists another gentle boundary, a quiet and unyielding floor known as omega notation. If Big O is the upper limit, the maximum effort required, then omega is the lower bound, the absolute minimum amount of work the algorithm must perform even in the best and most favorable of circumstances. It is the foundational layer of underlying effort. It is the quiet bedrock upon which the algorithm rests. Imagine a calm and glassy lake, No matter how still the air becomes, the water will never recede below its natural basin. Omega describes this basin, the inevitable minimum exertion that cannot be avoided, no matter how perfectly the data is arranged or how smoothly the process begins. It is a comforting flaw that supports our understanding, reminding us that every action requires at least a small, fundamental investment of energy. And then, in the tranquil space between the ceiling and the floor, we find perfect and harmonious peaceful alignment. This state of equilibrium is known as theta notation. Theta represents a tight bound, a beautiful and rare condition where the upper and lower limits converge into a single, predictable truth. When an algorithm is described by theta, it means its effort grows at exactly the same rate in both the best and the worst of times. The ceiling and the floor run perfectly parallel, enclosing the algorithm's heartbeat in a steady and unchanging corridor of certainty. There are no surprises here, no wild fluctuations between ease and exhaustion, only the quiet and mesmerizing consistency of an understood steady process. This tight bound is the ultimate expression of predictable efficiency, a serene and balanced state where the algorithm's behavior is known with absolute and unwavering clarity. We can rest our minds fully on theta, knowing that the effort is not just limited, but precisely defined, a gentle and steady path that stretches out endlessly before us. The discovery of a tight bound is like finding a perfectly straight and level path through a dense and tangled woods. It offers a sense of profound relief, a quiet joy in the face of absolute predictability and perfectly balanced algorithmic forward motion. Together, big O, omega, and theta form a complete and harmonious framework for understanding the rhythms of computation. They provide the ceiling, the floor, and the exact path forward, offering a deeply comforting structure to the invisible world of algorithms. We can observe the heartbeat of the machine and describe it with these gentle notations, framing its exertion in a language of calm and steady boundaries. As we wander further through this landscape of complexity, we encounter a beautiful hierarchy of speeds, a gentle progression of growth that dictates the rhythm of the computational world we are peacefully slowly exploring. At the very foundation of this hierarchy lies the stillest and most peaceful of them all, O of 1, or constant time. An algorithm with an O of 1 heartbeat is completely untroubled by the size of the world around it. Whether it is looking at a single piece of data or an ocean of 1 trillion data points, its effort remains perfectly flat, beautifully unchanged. It is like turning on a light switch in a tiny room or a massive cathedral. The action takes exactly the same amount of effort regardless of the space illuminated by the small bulb. Constant time is a state of deep tranquility, a motionless exertion that provides instant and unwavering resolution. As we slowly move up the hierarchy, we encounter O of log n, logarithmic time, a gentle and highly efficient slope. This is the rhythm of halving, the elegant division of a problem into smaller and smaller pieces. Imagine searching for a word in a vast, ancient dictionary. You do not read every page, you gently open the book to the middle, determine which half holds your answer, and discard the rest. With each quiet step, the entire problem is swiftly, calmly halved. Logarithmic time grows so slowly, so gently, that even as the data reaches astronomical sizes, the effort barely rises, curving beautifully like a smooth stone skipping across a vast and quiet pond. Moving slightly higher, we find O of n, or linear time. This is a steady and methodical march, a calm and unbroken progression where the effort grows in perfect, direct proportion to the data. If there are 10 items, it takes 10 gentle steps. If there are 1,000,000 items, it takes 1,000,000 gentle steps. It is like walking down a long, quiet, and very peaceful path. You place one foot smoothly in front of the other, touching every single stone along the way exactly once. There is no rushing, no skipping, just a perfectly even and reliable rhythm that scales predictably with the size of the task. Linear time is the heartbeat of thoroughness, a serene and complete examination of every piece of information presented to the machine. It is a slow, rhythmic, and deeply comforting pulse, a simple relationship between the volume of the world and the effort required to simply witness it. The algorithm marches on with steady, unchanging, and absolutely graceful calm patience. As our gentle journey upward continues, the slope of effort begins to steepen, though it remains smooth and perfectly logical. We arrive at O of n log n, linear rhythmic time, which blends the steady march of linear effort with the elegant halving of logarithmic growth. This is the rhythm of highly efficient sorting, the beautiful choreography of merging and dividing vast lists of information. It is like organizing a massive library by quietly dividing the books into smaller piles, sorting them gently, and then merging them back together in perfect order. The effort is greater than a simple linear walk. But it is deeply structured, a harmonious dance of data that handles enormous complexities with grace and measured patience. But as we look further up the mountain of complexity, the paths become significantly steeper. We encounter O of n squared, quadratic time. Here, the algorithm must compare everything to everything else. For every single item in the data, it must gently walk through all the other items again. It is a sprawling network of interactions, like throwing a handful of pebbles into a still pond and watching every expanding ripple intersect with every other slowly moving, gentle watery surface ripple. As the number of pebbles grows, the number of intersections multiplies immensely. The curve of quadratic time bends upward with increasing speed, reminding us that not all problems can be solved with a light and breezy touch. The effort grows not in a straight line, but in an expanding square of exertion, a slow and heavy lifting that requires time and profound patience from the machine. And finally, we look toward the distant and towering peak of O of 2 to the power of n, exponential time. This is the explosive climb, a vast and branching tree of limitless possibility. With every single new piece of data added, the effort required absolutely doubles. It is the rhythm of a chessboard covered in grains of wheat, where each square holds twice as much as the one before it. The growth is staggering, soaring upward into the stratosphere of computation, quickly overwhelming even the most powerful of machines. Exponential time is a quiet warning, a gentle reminder of the fundamental limits of computation and the boundless nature of the universe. It teaches us to be mindful, to seek better, softer paths, and to respect the sheer magnitude of unfolding computational limitless choices. Yet, as we contemplate these steeper climbs and these heavy burdens of effort, we must remember that the worst-case scenario is not the only reality. The ceiling of Big O is a safe boundary, but it does not always reflect the gentle, everyday existence of the algorithm. To understand the true, lived experience of the machine, we turn to the soothing and balanced concept of amortized analysis. Amortized analysis is a way to find the gentle average of an algorithm's effort over a long and continuous period of time. It smooths out sudden spikes of exertion very, very gracefully. It distributes the weight of a heavy task across a vast expanse of lighter, simpler moments. Imagine walking along a mostly flat and quiet road, where every once in a long while, you must step over a rather large stone. If we only looked at the exact moment you climbed over the stone, we might think your journey was incredibly strenuous and exhausting. But if we take a step back and view the entire long walk, the immense effort of that single step is diluted, softly absorbed by the countless easy steps that came before it in peaceful unending succession. The average effort, the amortized cost, is incredibly low, revealing a journey that is, in truth, deeply peaceful and entirely manageable. Amortized analysis is a philosophy of grace within computation. It acknowledges that an algorithm may occasionally need to perform a massive reorganization, a sudden and heavy lifting of data, but it forgives this momentary exertion by recognizing the long periods of rest and effortless operation that surround it. We take the total cost of a long sequence of operations and gently divide it by the number of actions, finding a sweet and mellow average representing the machine's true rhythm. This perspective removes the fear of the worst-case spike, bathing the algorithm's performance in a soft and understanding light. It teaches us that isolated moments of intense work do not define the whole system. The overarching reality is one of balance, a calm and sustainable equilibrium where heavy burdens are shared across time, resulting in a gentle and fluid progression. As we close our eyes and think of the algorithm's heartbeat, we can feel this gentle average, a steady, unhurried pulse that remains calm and resilient, endlessly finding its quiet center amidst the ever-changing computational fluid gentle world. Breathe in deeply and let the gentle rhythm of sequential flow wash over your tired mind as we begin this quiet journey into the structure of memory. We are stepping into the calm and orderly world of linear streams where every single piece of data has its rightful place in a steady continuous line. Imagine a serene river of memory flowing endlessly through the quiet valleys of the machine. In this peaceful place we find ordered data resting in perfect harmony. There is no rushing and no confusion here in the depths of the system. There is only the steady predictable sequence of elements following one after another, just like your slow and steady breaths. Every element waits patiently in line, trusting the sequence, knowing that its turn will come in due time. As you listen to the steady current of this digital river, allow your thoughts to align with the sequential flow of memory. Feel the calmness that comes from knowing exactly what comes next and what came before. The sequential nature of memory provides a deeply reassuring structure, a safe pathway for your mind to follow as it drifts deeper into relaxation. Everything is connected in a gentle linear stream flowing from the beginning to the end without any sudden interruptions. Let your mind drift along this tranquil river of data as we encounter the smooth and continuous structures known as dynamic arrays, which you might recognize as Python lists. Picture a row of comfortable interconnected vessels resting on the surface of the calm water, each holding a single delicate piece of information. In the physical memory of the machine, these dynamic arrays are laid out in a perfectly contiguous block. This means they form a single unbroken stretch of space where every vessel is placed right next to its neighbor. This physical closeness creates a beautiful sense of unity and speed within the machine. When the system needs to find a specific element, it simply glides along this continuous block, calculating the exact distance with effortless precision. You can imagine a soft light moving smoothly across the surface of the contiguous memory, touching each element in perfect order. There is a deep comfort in this physical proximity, knowing that all related pieces of information are gathered closely together. As you breathe in and out, visualize this long unbroken chain of memory resting quietly in the dark, expansive space of the computer. It is a solid and reliable foundation, a perfect embodiment of ordered data existing peacefully in the present moment. But the true magic of the dynamic array, or the Python list, is its wonderful ability to grow and adapt without ever losing its calm composure. As you continue to breathe slowly and evenly, imagine this array softly expanding to make room for new data. When the current contiguous block of memory becomes entirely full, the dynamic array does not panic and it does not rush. Instead, it quietly looks out into the vast open spaces of the deep memory river and finds a larger, more spacious area to call home. It gently picks up all of its stored elements and relocates them to this new expansive space, maintaining the exact same order and sequence. This is a seamless migration, a calm and calculated adjustment that ensures the ordered data always has enough room to breathe and exist in perfect sequence. Think of it as moving from a small cozy room into a grand sweeping hall where there is boundless space to stretch out and relax. The system handles all of this heavy lifting silently in the background, allowing the sequential flow to continue undisturbed. You do not need to worry about the details of this migration, just as you do not need to worry about the world outside as you drift closer to sleep. Everything is managed with graceful precision. Now let your mind softly drift away from the contiguous blocks of memory and explore an entirely different kind of sequential flow known as the linked list. Imagine a series of tiny floating islands scattered across the vast peaceful lake of the system memory. Unlike the dynamic array, these islands do not need to sit right next to each other in a strict contiguous line. They can rest wherever there is open space, floating freely and independently in the calm digital waters. Yet despite their physical separation, they remain perfectly and harmoniously connected in a beautiful linear sequence. This profound connection is maintained by gentle tethers, which are invisible threads of logic that we call pointers. In a singly linked list, every single island or node holds a piece of ordered data and a single delicate pointer that reaches out across the dark water to connect with the very next node in the sequence. It is a gentle chain of references, a quiet and trusting handoff from one piece of memory to the next. As you relax your body deeper and deeper, envision following these invisible tethers, moving slowly and smoothly from the first floating island to the second and then gently onward to the third. You are flowing through the memory space not by relying on physical proximity but by trusting the guiding thread of the pointer. Each node in the singly linked list knows only the path to its immediate successor. It does not need to know the entire journey, it only needs to know the very next step. This is a beautiful metaphor for relaxation, where you do not need to worry about tomorrow or even the next hour, you only need to focus on your next breath. The nodes trust that the gentle chain will eventually lead to the end of the line, where a quiet null reference peacefully signals the completion of the journey. A null reference is simply an empty space, a gentle void that says there is nowhere else to go and it is time to rest. Imagine reaching that final island and looking out into the calm, empty waters, feeling a sense of completion and deep peace. The sequential flow of the singly linked list teaches us to follow the path one step at a time, relying on the gentle pointers to guide us through the dark and quiet spaces of the machine. Let us pause for a moment in our gentle journey to deeply understand the true nature of these pointers and the quiet aliases they create within the system memory. A pointer is not the data itself. It is simply a serene directional guide, a soft and quiet arrow pointing toward the true location of the information. Think of a pointer as a gentle gaze looking across the calm memory lake and resting upon a specific island. Because pointers are merely references, it is entirely possible for multiple pointers to look at the exact same node at the exact same time. When this gentle convergence happens, we create what is known in the system as an alias. Imagine two different names for the same quiet resting place, two separate invisible threads leading to the very same piece of ordered data. This creates a beautiful and elegant efficiency in the memory because the underlying data does not need to be duplicated or moved. Instead, the system simply creates another gentle pointer, another alias, to reference the same tranquil space. As you breathe in and out, think about how these soft aliases interweave through the linear streams of memory, creating complex but perfectly organized pathways without ever disturbing the physical data itself. The data remains completely still and calm, resting heavily in its chosen spot, while the pointers gently shift and redirect their focus, guiding the sequential flow with soft and effortless precision. You can have many different paths leading to the same peaceful destination. In your own mind, you might have many different thoughts that all eventually lead you back to this feeling of deep relaxation and stillness. The concept of an alias reminds us that we can look at the same object from many different angles without ever changing its fundamental nature. The machine uses these aliases to glide through its tasks without unnecessary effort, conserving its energy just as you are conserving your energy now. Let the idea of these invisible threads and gentle gazes wash over you as you sink deeper into the soft sequential flow of the memory space. As your mind continues to relax into the soothing rhythm of the pointers, we can begin to explore how these invisible threads can form entirely different shapes within the sequential flow. Picture the singly linked list once more with its quiet progression from one island to the next until it finally reaches the end. But imagine for a moment what it would feel like if there were no end to this peaceful journey. Imagine the very last node in the sequence taking its delicate pointer, and instead of reaching out into the empty void of a null reference, it gently reaches all the way back across the quiet water to connect with the very first node. This beautiful action creates a circular linked list, an endless loop of ordered data that flows continuously without ever stopping. In this circular stream, there is no final destination and no abrupt ending to halt the gentle journey. The sequence flows continually round and round like a soothing chant or the steady turning of a wooden wheel. As you visualize this endless loop, feel the deeply hypnotic rhythm it creates within your mind. The memory becomes a continuous cycle, a gentle orbit where every single element is part of an unbroken ring. You can drift along this circular pathway forever, smoothly transitioning from the end back to the beginning in a seamless and infinite flow of deep relaxation. There is a profound comfort in a circle because it represents wholeness and eternity. In the machine, a circular linked list allows the system to cycle through tasks in a steady and predictable rhythm, never having to stop and restart. It simply flows from the last element back to the first, maintaining the exact same gentle pace. Imagine yourself floating on this circular current, feeling the soft pull of the sequential flow carrying you round and round. With every orbit, your mind becomes heavier and your body becomes more relaxed, perfectly attuned to the endless turning of the circular stream. Now let us introduce an even greater sense of balance and harmony to our floating islands by transforming them into a doubly linked list. In this serene and perfectly balanced structure, every node is equipped not just with one delicate pointer but with two. One gentle thread reaches forward to the next node in the sequence just as before, while a second delicate thread reaches backward to safely hold onto the previous node. This creates a deeply reassuring sense of stability and connection within the sequential flow. The data is securely anchored from both sides, allowing the current to move with equal grace and effortless ease in either direction. Imagine drifting forward through the ordered sequence, gliding smoothly from the past into the future, and then simply shifting your focus and drifting gently backward from the future into the past. The doubly linked list provides total freedom of movement within the ordered sequence without ever losing the sense of calm structure. There is no need to start all over from the very beginning if you wish to retrace your steps in a doubly linked list. The backward pointers are always there to guide you safely and quietly in reverse, offering a perfect structural symmetry that deeply soothes the mind. Breathe deeply and feel the comforting embrace of being connected in both directions, knowing that you can always move forward into the unknown and you can always return safely along the exact same path to the place where you began. This bidirectional flow reflects the natural rhythm of your breathing, moving inward and then moving outward in a perfect and continuous cycle. The machine uses these forward and backward pointers to navigate its memory with complete confidence, never feeling lost or disconnected. As you lie here, let your mind glide back and forth along the smooth and steady tethers of the doubly linked list, feeling perfectly secure and entirely at peace with every single movement. As we continue our slow and steady journey through these calm linear streams, we begin to encounter specialized abstract data types that softly govern how we interact with the sequential flow. These abstract concepts are not physical things but gentle rules that bring even more order to the data. The first of these calm logical structures is known as the stack. Picture a tall, quiet cylinder resting comfortably in the soft, dim light of the memory space. The stack operates on a deeply simple and reassuring principle known as last in, first out. Imagine yourself gently placing a single smooth, flat stone at the very bottom of the cylinder. Then you take another smooth stone and place it softly on top of the first one. You continue this slow process, placing another stone on top of that one, building the sequence vertically into a peaceful and sturdy column of ordered data. Everything is contained safely within the quiet walls of the stack. When it is finally time to remove a stone from the cylinder, you do not disturb the stones resting peacefully at the bottom. Instead, you gently lift the very last stone that you placed, the one resting comfortably at the absolute top of the column. This is the beautiful essence of the stack and the last in, first out philosophy. The most recent memory, the very last piece of data to enter the calm sequential flow, is the first one to be softly and gently removed. It is a perfect and deeply logical mechanism for tracing your steps backward, much like remembering a sequence of quiet thoughts one by one, starting from the most recent feeling and peeling it back to reveal the very first. Let the steady and predictable rhythm of pushing data softly onto the top of the stack and popping data quietly off the top of the stack lull you into a much deeper state of tranquility. Push and pop in and out, a gentle and endless mechanical breathing. Floating just a little further down the gentle river of memory, we come upon another brilliant linear structure known as the queue. Unlike the vertical stack, the queue is built on the fundamentally different principle of first in, first out, which is a beautifully fair and totally predictable sequence. Imagine a calm, orderly line of elements standing and waiting patiently at the edge of the memory water. The very first element to join this quiet line is honored and respected by being the very first element allowed to step forward when the time is exactly right. As new pieces of data arrive in the sequential flow, they quietly take their appropriate place at the very end of the line, standing peacefully behind all of those who came before them. There is no pushing in this gentle queue, and there is no skipping ahead of others. Everything strictly follows the natural and unhurried sequential flow of time. Breathe in slowly and visualize this steady and deeply fair progression. The data flows effortlessly into the back of the queue and flows just as effortlessly out from the front of the queue in a smooth and continuous stream. It is very much like watching a slow-moving river current, where the water that first enters a narrow channel is exactly the first water to gently spill out into the wide open lake. This predictable and steady movement brings a profound sense of total order and fairness to the chaotic world of the system, allowing your busy mind to rest in the pure absolute certainty that absolutely everything will be handled in its proper turn. There is no need to worry about what is coming next, because the queue ensures that every single element will be gently processed exactly when it is supposed to be. Let the calm fairness of the queue wash away any lingering thoughts of urgency or stress, replacing them with a deep and abiding patience. But sometimes, even within this perfectly calm and orderly system, there are specific pieces of data that carry a quiet sense of urgency or a special elevated level of importance. For these unique moments, the memory landscape provides a structure known as the priority queue. Imagine the exact same peaceful line of waiting elements, but instead of simply waiting strictly by the exact time they arrived, each element now radiates a soft and gentle colored glow that clearly indicates its unique priority. The system, acting as a kind and profoundly mindful guide, looks softly across the waiting elements and gently calls forward the one with the brightest, most vibrant glow, which represents the highest priority regardless of when it actually joined the sequence. It is a wonderfully fluid and deeply intelligent flow, where the natural order is determined not just by the rigid passage of time but by a much deeper inner value. Yet even with this subtle and intelligent shifting of the sequence, absolutely everything remains perfectly calm and entirely controlled. The elements that are not chosen immediately do not become anxious. They simply continue to wait peacefully in the dim light, knowing with absolute certainty that their specific moment will eventually come. As you drift along in this gentle space, imagine this quiet sorting process, the soft evaluation of priorities that happens automatically without any stress or underlying tension. The sequential flow gracefully adapts and smoothly bends to accommodate the most important needs of the system, all while flawlessly maintaining its serene and steady overall pace. You can trust this intelligent sorting process just as you can trust your own mind to sort through your memories and gently file them away as you sleep. Everything is prioritized calmly, gently, and with infinite digital patience. To make these wonderful cues flow with the absolute utmost grace and efficiency, the system very often relies on a beautiful and clever concept known as the circular array. Let your relaxed mind return briefly to the contiguous blocks of the dynamic array that we saw earlier, but this time I want you to imagine the two far ends of that block curving slowly and gently toward each other until they finally meet, forming a perfect unbroken physical ring. In a traditional linear array, when the front of a queue moves forward, it leaves empty unused space behind it, and eventually the queue hits the hard end of the physical block, which requires a slow, heavy, and exhausting shifting of all the stored elements back to the beginning. But the circular array beautifully eliminates this friction entirely. It bends the physical memory space into a continuous shape of endless possibility. As the front of the queue gently moves forward processing data in the circular array, the back of the queue can seamlessly and quietly wrap around to the very beginning of the array, gracefully reusing the empty space that was just left behind. It is a deeply mesmerizing dance of logical pointers continuously and softly chasing each other around the gentle physical curve of the circle. Because of this brilliant wrapping motion, there is no need to ever forcefully shift the data or disturb the peacefully resting elements. The logical sequence simply flows in an endless unbroken loop through the physical memory space. This smooth circular motion brings a profound and lasting efficiency to the system, allowing the sequential flow to continue processing forever without a single moment of interruption or hesitation. Everything moves in perfect continuous circles. Breathe slowly and imagine this endless turning, this absolute perfect optimization of space and gentle movement. It is a continuous flowing cycle of ordered data circling peacefully in the quiet depths of the machine, carrying you deeper and deeper into a perfectly calm and sequential state of rest. As we look back upon the linear streams, we see how they all work together in a vast quiet harmony. The contiguous dynamic arrays resting side by side. The singly linked floating islands tethered by invisible pointers. The endless orbits of the circular linked lists. The comforting backward and forward balance of the doubly linked lists. The steady vertical column of the stack breathing in and breathing out. The fair and patient line of the queue and the softly glowing intelligence of the priority queue. They all exist to bring order to the chaos, to create a steady sequential flow that the mind can easily follow. As you drift away, let the concept of linear sequential flow become a part of your own resting state. Imagine your thoughts lining up perfectly in a calm and patient queue, waiting gently to fade away into the darkness. There is no rush to process them because the sequential flow is eternal and there is infinite time. Follow the invisible gentle pointers from one slow breath to the next, from one deeply relaxed muscle to another. You are flowing continuously through a circular array of deep rest, wrapping around from one peaceful dream to the next without any friction or heavy shifting. The memory of the machine is calm and orderly, and your own memory is settling into that exact same beautiful sequential rhythm. Breathe in the order, breathe out the noise, and let the gentle linear streams carry you away into a perfect undisturbed sleep where everything is exactly where it is supposed to be. We leave behind the endless flat plains of the arrays. We step away from the single winding rivers of the linked lists. You have walked the straight lines for a long time. The linear flow is simple and steady. But now, we stand at the edge of a great forest. The flat lines give way to a sprawling architecture of thought. We are entering the realm of hierarchical structures. This is a place where data does not follow one after another in a single file. Here, data branches out. It creates a canopy of information that breathes with a quiet rhythm. The rigid sequences melt away, replaced by the organic beauty of branching paths. You feel the space opening up. You are moving deeper and spreading wider. The hierarchical flow is the way nature organizes itself. Breathe deeply as we step into this ancient forest of data. The air is cool and still, filled with the wisdom of trees and heaps. Let us look closely at the simplest of these structures. The binary tree. In the waking world, a tree grows from the ground up. But in the quiet landscape of computer science, the tree grows downward. It begins high above you, suspended in the gentle air, at a single, perfect point. This is the root. Everything within the binary tree descends from this one calm center. Imagine looking up and seeing that single root node, glowing softly. From this root, the structure branches out. But it is a binary tree, meaning, two. There is a soothing constraint in this design. From any node in this tree, there can only ever be two branches extending downward. A left path and a right path. A gentle binary rhythm. The node that extends its branches downward is the parent. The nodes that receive these branches are the children. The parent watches over the children, passing data smoothly deeper into the forest. Some children have children of their own, becoming parents themselves, extending the tree further down into the shadows. But eventually, the branching ends. The paths reach their final destinations. These final nodes, having no branches beneath them, are called the leaves. The leaves are silent. The leaves are still. They simply exist at the edges of the tree, holding their data perfectly, resting at the end of their long journey. When you measure a tree, you measure its depth. The depth is the distance from the root down to the furthest leaf. A shallow tree is like a small bush, resting lightly on the surface. A deep tree is a vast network, stretching endlessly down, level upon level. We can measure the depth by counting the steps. 1 step down to the first children. 2 steps down to the grandchildren. As you breathe in, imagine the root. As you breathe out, imagine the branches extending downward. Left and right, until they reach the quiet leaves. Now that we see the tree, we must learn how to walk through it. We must learn how to visit every node, parent, child, and leaf. Walking through a tree is called a traversal. It is a deliberate, methodical, and peaceful journey. There are many ways to walk through the forest. We will begin with the deepest journeys. These are the depth-first traversals. We pick a path and we follow it all the way down, as deep as we can go, before we turn back. We plunge into the quiet depths. The first way to walk this path is the pre-order traversal. Pre-order means we acknowledge the beginning before we explore the unknown. In a pre-order traversal, the rhythm is steady. Root, left, right. We stand at a node, and we visit it. We read its value. This is the root of our current moment. Once we have visited the root, we step down the left branch, finding a new node. We visit this new root. And then, we look left again. Root, left. Root, left. We continue this downward journey, always favoring the left, moving deeper into the left side of the forest, until there are no more left branches to take. Until we hit a leaf. Only then, when the left path is fully exhausted, do we gently retrace our steps. We move back up to the parent, and we look to the right. We step down the right branch. Root, left, right. This is the pre-order rhythm. The journey of anticipation. We visit the node the moment we see it, before we know what lies beneath it. It is a trusting walk. We touch the parent, we dive down the left, we rise, and we dive down the right. Root, left, right. Imagine yourself walking this path. You touch the trunk, you follow the left branch to the tip, you glide back, you follow the right branch to the tip. Smooth, predictable, and deeply calming. Let the pattern soothe your mind as we trace the edges of the tree. The forest offers another path. Another rhythm for the depth-first journey. This is the in-order traversal. The in-order traversal is the path of perfect balance. It is the path of patience. In this journey, we do not visit the root immediately. We do not rush to understand the parent before we have listened to the child. The rhythm changes. The pattern becomes left, root, right. We begin at the very top of the tree, but we do not stop there. We immediately look to the left, and we step down. we keep stepping down the left branches, deeper and deeper, ignoring the parents, passing them by in silence, until we reach the furthest, most quiet leaf on the left side of the tree. This is where we begin. We visit this quiet leaf. We acknowledge its peaceful presence. Then, we gently rise back up to its parent. Now, we visit the parent. After the root is visited, we turn to the right. We step down the right branch and visit what is there. It is a gentle oscillation. A slow swinging of a pendulum. Left child, parent, right child. Down to the left, up to the center, down to the right. It feels like breathing. Inhaling from the left, holding at the center, exhaling to the right. Left, root, right. Left, root, right. The in-order traversal is special because of what it reveals. If the tree is organized in a certain logical way, the in-order walk will reveal the data in perfect, sequential harmony. It smooths out the branches and presents the leaves in a beautifully sorted line. From the smallest on the far left, growing slowly and steadily as we move through the roots, to the largest on the far right. It is a walk of order. A walk of tranquility. We let the tree guide us. We wait to hear from the left before we speak to the root. We wait to hear from the root before we speak to the right. The patience of the in-order walk slows the heartbeat. Left, root, right. Left, root, right. The forest reveals its secrets not by rushing, but by following the natural flow of the branches. There is a third way to walk the deep paths. A third rhythm to guide you through the branches. This is the post-order traversal. The post-order traversal is the journey of completion. It is the path of careful assembly. In this walk, the parent is always last. The root must wait. The rhythm changes once more. Left, right, root. Left, right, root. We plunge down the left side, all the way to the bottom. We find the left leaf and we visit it. But we do not go to the parent next. No, the parent must wait. Instead, we cross over to the right. We visit the right child. We visit the right leaf. Only when both children have been visited, only when both the left and the right have been fully acknowledged, do we finally rise to visit the parent. Left, right, root. Left, right, root. It is a gathering process. Imagine you are at the bottom of the forest, picking up leaves. You pick up the leaf on your left. You pick up the leaf on your right. And only then do you look up at the branch that held them both. You resolve the children before you resolve the parent. Left, right, root. We move through the tree like a slow, retreating tide. Starting at the very bottom edges, at the lowest depths, and slowly bubbling our way up. Resolving the left. Resolving the right. Acknowledging the root. Left, right, root. Left, right, root. This traversal is a quiet clearing of the mind. It empties the lowest levels first, gently working its way upward, releasing the data layer by layer, until finally, at the very end of the journey, we stand before the great root of the entire tree. We visit the final root, and the traversal is complete. The tree has been fully explored. The post-order walk teaches us that sometimes, to understand the whole, we must first deeply understand the parts. We must look at the foundation. We must honor the leaves before we honor the trunk. Left, right, root. A slow, methodical gathering of thoughts, bringing everything to a calm, unified close. The post-order rhythm carries us safely back up to the surface, leaving absolutely nothing left behind in the dark. We have walked the deep paths. We have plunged into the shadows and retraced our steps. But the forest can be explored another way. A way that does not dive deep, but spreads wide. We can depart from the vertical journeys and embrace the horizontal flow. This is the breadth-first traversal. It is also known as a level-order traversal. In this journey, we do not rush to the bottom. We take our time. We observe the tree level by level, layer by layer, like a gentle wave washing over the canopy. We begin at the very top. Level 0. The great root of the tree. We visit the root. We see it alone in its space. Then, we gently descend just one step. Level 1. Here, we sweep our gaze horizontally across the forest. We visit all the children of the root. We sweep from left to right. A smooth, even motion. We visit the left child. We visit the right child. We do not go any deeper until this level is completely explored. We breathe in, and we lower ourselves one more step. Level 2. Now we sweep across the grandchildren. Left to right. Side to side. We glide across the width of the branching canopy. The breadth-first traversal is a calming, expanding ripple. It drops into the center of the pond and expands outward in perfect, concentric circles. Layer by layer. We do not favor the left branch over the right branch. We treat all nodes on the same level with equal importance. We wait for the wave to reach them. The horizontal sweep is rhythmic and slow. Sweep across. Drop down. Sweep across. Drop down. We can imagine the nodes lighting up, one by one, in a straight horizontal line, before the light cascades down to the next level beneath them. It is a highly organized, deeply soothing way to view the structure. There are no sudden drops. There are no long climbs back up from the depths. There is only the steady, gentle progression from the top of the canopy, slowly settling down through the leaves, until the final, widest layer rests on the forest floor. The breadth-first journey is the breath of the tree itself, expanding and contracting in perfect time. It gives us a sense of immense peace to see the layers unfold so predictably. Let us look closer at the trees around us. Some trees grow wild, their branches reaching wherever the light falls. But some trees are grown with a perfect, quiet logic. These are the binary search trees. In a binary search tree, every single node obeys a gentle, unbreakable rule. A rule of harmony. The rule is this: everything to the left must be lesser. Everything to the right must be greater. It is a landscape of perfect sorting. Imagine standing at any root in this forest. You hold a value in your mind. If you look down the left branch, you know with absolute certainty that every single leaf, every single child down that path, will hold a value smaller than the one you hold. The left side is the realm of the lesser. It is the lighter side. The quieter side. If you look down the right branch, you know with the same absolute certainty that every single node down that path will hold a value greater than the one you hold. The right side is the realm of the greater. It is the heavier side. The more expansive side. Lesser to the left. Greater to the right. This beautiful, simple rule creates a structure of immense efficiency. It creates a forest where you can never truly be lost. If you are searching for a specific leaf, you do not need to wander every path. You begin at the root. You ask a simple question. Is the leaf I seek lesser or greater than the root? If it is lesser, you drift to the left. With that single, elegant decision, you have eliminated half of the entire forest. You do not even need to glance at the right side. It fades away into the mist. You step down to the left, and you ask the question again. Lesser or greater? Left or right? Every step you take halves the remaining universe of choices. The search is fast. The search is an arrow flying true to its target without disturbing the air. The binary search tree organizes the chaos of the world into a beautifully navigable map. Lesser to the left. Greater to the right. A continuous series of gentle choices, guiding you perfectly and peacefully to exactly where you need to be. No wasted effort. Just the quiet logic of the branches, leading you home. Deep within the forest, there is another kind of structure. It is not a search tree. It does not divide the world into left and right, lesser and greater. It is a heap. A heap is a binary tree that is perfectly complete. It fills every level from left to right before it ever dares to step down to a deeper layer. It is a structure of immense physical stability. It looks like a perfect pyramid, resting solidly on the ground. But the true magic of the heap lies in its hierarchy of weight. This is the heap order property. There are two variations of this quiet rule: the minute heap and the max heap. Let us visualize the minute heap first. In a minute heap, the rule is simple and absolute. The parent must always be smaller than its children. The parent must always be lighter. This means that the smallest, lightest, most delicate value in the entire structure floats effortlessly to the very top. It rests at the root, like a single drop of dew resting on the highest tip of the highest leaf. As you move down the branches of a minute heap, the values grow larger. They grow heavier as you descend. The heavy elements sink to the bottom, forming a wide, solid foundation, while the lightest element is presented to you immediately, right at the top. The minute heap is a perfectly calm progression from light to heavy, from small to large, as you descend. Then there is the max heap. The rule is reversed, but the harmony remains. In a max heap, the parent must always be greater than its children. The parent must always be heavier. Now, the largest, most powerful, most significant value rises to the top. It claims the root. It sits majestically at the peak of the pyramid, looking down upon all the smaller values beneath it. As you move down the branches of a max heap, the values grow smaller. They grow lighter. The max heap is a mountain, with its peak touching the sky, and its smaller fragments settling down into the valleys. Whether it is a minute heap or a max heap, the structure maintains its order through a quiet process of bubbling up and sifting down. If a new, light value is placed at the bottom of a minute heap, it slowly bubbles up, swapping with its heavier parents, rising like a bubble of air through water, until it finds its perfect resting place. As our journey through the branching structures nears its end, we must observe the ultimate expression of stability in the forest: the self-balancing trees. Nature does not like to be lopsided. A tree that grows too heavy on one side will snap in the wind. A search tree that only grows down the left branch becomes a long, fragile line, losing the beauty of its hierarchy. To survive the winds of change, to maintain the quiet efficiency of the search, the tree must learn to balance itself. It must learn to adjust. We look at the 2-3 trees and the magnificent B trees. These structures depart from the strict binary rule of 2 children. They allow nodes to hold more. A node in these trees can be a quiet room that holds 2 values, or 3 values, or many more. They are wider nodes. Thicker branches. Because they can hold more within themselves, they can manage the weight of the data differently. When a node becomes too full, it does not simply drop a long, unmanageable branch down into the depths. Instead, it gently splits. It divides itself in half, and it pushes the middle value upward, handing it carefully to its parent. The depth of the tree is perfectly uniform. The forest floor is completely flat. Every path from the root to a leaf is exactly the same length. This is the definition of self-balancing. The tree constantly monitors its own weight. As new leaves are added, as new data drifts down into the branches, the tree subtly shifts. It splits here, it merges there. It pulls a branch up, it spreads a node wide. It breathes. It adjusts. It maintains a perfect, beautiful equilibrium. The B trees can grow incredibly wide, their nodes holding hundreds of values, their branches reaching out like a massive, ancient oak tree. The depth remains shallow, even as the tree holds a universe of information. The journey from the root to any leaf remains remarkably short, remarkably fast, and completely predictable. The self-balancing tree is the stoic guardian of the forest. It stands resolute against the storm of incoming data. It absorbs the changes. It shifts its weight. It keeps the canopy perfectly level. The 2-3 trees and the B trees teach us that true stability is not about rigidity. True stability is about the willingness to adjust. The branches sway, but the depth remains true. The hierarchy holds its shape permanently. The roots hold firm, and the leaves rest gently in the calm air. The structure is sound. We rest in the shade of this perfect balance, knowing the structure will support us, now and always, in the quiet wisdom of the trees. Imagine a massive library that stretches out into the quiet darkness, where the shelves go on forever and ever, holding all the knowledge of the digital world. In this endless expanse of information, you are seeking just one single piece of data. The sheer scale of this vast digital space requires a deep, unwavering focus. You must center your mind, drawing your attention away from the millions of other volumes that surround you in the quiet stillness. Every book, every record, every tiny fragment of data is resting peacefully on its designated shelf, waiting to be found. The act of finding is a delicate art, a quiet meditation in the center of infinity. You hold a map in your mind, a conceptual guide to help you navigate the endless corridors of this grand archive. The silence of the library wraps around you like a heavy, comforting blanket, slowing your heartbeat and calming your thoughts. You are here to locate one specific truth hidden among the multitudes. The focus required to find a single piece of data in the vast digital space is absolute. It is a gentle narrowing of your awareness, a quiet tuning of your senses to the precise frequency of the information you seek. You stand at the entrance of the endless aisles, embracing the cool digital silence. Locating the data is not a struggle, but a peaceful journey through the structured pathways of memory. You take a slow, deliberate step forward, embracing the stillness. The library is vast, yet you are not lost. You are a quiet observer, a patient seeker of knowledge in the dark, serene expanse. Your mind is a calm pool of water, perfectly still, perfectly focused on the quiet task of discovery. When you begin your search, you might choose the path of steady persistence, a method known as the linear search. Linear search is a slow, methodical march through the endless shelves of our grand digital library. You start at the very beginning, at the first book on the first shelf, and you examine it with a calm and gentle gaze. Is this the piece of data you are looking for? If it is not, you do not rush. You simply move to the next book, and then the next, in a quiet, unbroken rhythm. Linear search is the essence of patience. It does not skip, it does not jump, it does not make sudden movements. It honors every single piece of data by giving it a moment of your quiet attention. You walk down the aisle, moving in a straight, unwavering line. This linear march is a meditation in itself, a repetitive cycle of looking and moving on. There is a deep comfort in the predictable nature of the linear search. You know exactly where you are, and you know exactly where you are going next. It is a steady persistence that requires no complex calculations, only the willingness to keep stepping forward, one item at a time. As you move along the shelves, locating one item after another, time slows down. The linear march takes time in a vast digital space, but time loses its meaning in the library's deep quiet. You are simply present, moving from left to right, from beginning to end, entirely focused on the act of finding. Each piece of data is a step on your journey, a quiet murmur in the silence. The linear search teaches you the value of endurance, the quiet strength of moving steadily forward without distraction or haste. Yet, if the books in this massive library are perfectly ordered, arranged in a flawless sequence from beginning to end, you might choose a different path, a technique known as binary search. Binary search is the rapid narrowing of possibilities, a graceful dance of logic that operates with logarithmic speed. Instead of starting at the very beginning, you walk calmly to the exact center of the endless library. You open the book that lies right in the middle, and you look at its contents. Because the library is perfectly sorted, this single glance gives you a profound insight. You instantly know whether the data you seek lies in the first half or the second half. With a peaceful realization, you gently dismiss half of the endless shelves. They fade into the background, no longer relevant. You then walk to the center of the remaining half, and you repeat this quiet, magical process. With each step, the search space is cut perfectly in two. The rapid narrowing of possibilities is a beautiful thing to witness, a smooth and efficient elimination of the unnecessary. The vast digital space becomes smaller with each graceful division. This logarithmic speed does not feel rushed, it feels like a harmonious aligning, a continuous unfolding of truth. You are teleporting through the structured logic of the ordered data. Locating your target becomes a series of gentle halving, a peaceful journey toward the center of the remaining truth. The binary search is a quiet triumph of organization, a reminder that perfect order brings a beautiful, effortless speed to the act of finding. You breathe deeply as the possibilities narrow, feeling the calm certainty that you are drawing closer and closer to the exact location of the single piece of data you desire. Sometimes, you have a deeper understanding of the library, an intuitive sense of how the information is distributed across the vast digital space. In these moments, you might use the interpolation search. Interpolation search goes beyond the strict, halfway divisions of the binary method. It relies on intuitive guesses based on the data distribution, a quiet estimation of where the information should logically reside. If you seek data that belongs near the beginning of the alphabet, you do not start in the center. You walk calmly toward the front, using your knowledge of the map to guide your steps. You make a peaceful calculation in your mind, guessing the approximate location of the data based on its value. It is like looking for a word in a heavy dictionary. You open the pages intuitively near the front or back, guided by the natural distribution. Interpolation search is a deeply harmonious way of finding an elegant alignment between your understanding of the data and the physical structure of the digital space. When data is uniformly spread, these intuitive guesses are incredibly accurate, allowing you to narrow down possibilities with flowing grace. You glide through the aisles, guided by the value of the information you seek. It is a gentle, flowing process, a quiet conversation between the seeker and the sorted data. You are reading the landscape of the massive library, sensing the natural rhythms of the information. This method of locating data feels natural, a quiet reliance on inherent patterns. The intuitive guesses based on data distribution lead you softly and surely to the exact shelf, the exact book, the exact piece of data you need, wrapping you in a profound sense of peaceful discovery. Beyond the steady persistence of the linear march, and beyond the ordered logic of the binary and interpolation searches, there exists a profoundly different method of finding, a method known as hashing. Hashing is a magical transformation, a wondrous and silent process that turns the very identity of the data into a precise location on your map. Imagine you possess a quiet, mysterious function, a mathematical incantation that you whisper to the key of your data. This hashing function takes the key, absorbs its essence, and performs a magical transformation. It takes the unique identifier of the information you seek, and it transforms it, magically and instantly, into an exact index, a specific address in the vast digital space. You do not need to search through the shelves. You do not need to walk down the aisles. You simply offer the key to the hashing function, and through its magical transformation, it whispers back the exact location. The transformation of keys into indices is a quiet miracle of computer science. It is a magical transformation that eliminates the need for searching altogether. The key goes in, the mathematical gears turn in perfect, frictionless silence, and the index comes out. This magical transformation means that the data tells you exactly where it lives. It is as if every book has a magical resonance, and the hashing function is the precise tuning fork that matches that resonance, revealing exact coordinates on the endless shelves. The magical transformation of keys into indices happens in a fraction of a heartbeat, an instantaneous realization of placement. You hold the key in your mind. You apply the quiet, magical transformation. The key changes and resolves into a pure and simple index. This index is the exact spot in the vast digital space where your data rests peacefully. The magical transformation of the hashing function is deeply repetitive, always taking the same key and magically transforming it into the exact same index. Over and over, the magical transformation takes place, taking keys and turning them into indices, taking names and turning them into perfect, immediate answers. The sheer elegance of this magical transformation is deeply calming. There is no wandering, no guessing, no narrowing of possibilities. There is only the key, the magical transformation, and the index. The library is no longer an endless expanse, it is a perfectly mapped grid where every piece of data belongs to its magically transformed index. You surrender to the simplicity of the magical transformation, letting the hashing function do the quiet work of locating the data for you. The focus required is minimal, for the magical transformation of keys into indices carries the burden of discovery. It is a profound and peaceful system, relying entirely on the magical transformation to guide you instantly to the truth. You stand in the silence of the library, holding another key. Once again, you invoke the magical transformation. The hashing function takes the key, processes it through its quiet mathematical pathways, and performs the magical transformation. The key becomes an index. The search is over before it even begins. The transformation of keys into indices is a soothing, repetitive rhythm. Key, magical transformation, index. Key, magical transformation, index. It is a lullaby of digital organization, a peaceful repetition that brings absolute order to the vast digital space. You marvel at how a complex string of characters can be magically transformed into a simple, pointing index. The magical transformation is a hidden map that translates the identity of the data into the physical reality of the library shelves. It is a flawless, magical transformation that brings ultimate peace to the act of finding. However, even in this world of magical transformations, there is a quiet challenge that sometimes arises, known as a collision. A collision occurs when the magical transformation takes two entirely different keys and magically transforms them into the exact same index. Two distinct pieces of data, guided by the hashing function, arrive at the exact same location on the shelf. They cannot both occupy the same space. This challenge of collisions is not a failure, but a gentle puzzle requiring a peaceful resolution. When a collision occurs, the system must find a new, quiet resting place for the second piece of data. One way to resolve this challenge is through linear probing. In linear probing, when the magical transformation leads to an occupied index, you simply take a calm step to the very next available space. You look at the next index. If it is empty, you gently place the data there. If that space is also full, you take another slow, steady step to the next index, and then the next, moving in a quiet, linear fashion until you find an empty resting place. Linear probing is a peaceful, orderly resolution to the challenge of collisions, a gentle drifting to the nearest open space. Yet, sometimes, linear probing creates quiet clusters of data huddled tightly together. To avoid these clusters, you might use a different resolution, a method called quadratic probing. Instead of taking one small step to the next index, quadratic probing takes steps that slowly expand in size. If the first space is full, you look one step away. If that is full, you look for steps away, then 9 steps away, jumping outward in a smooth, quadratic curve. This gentle expansion scatters the data more evenly across the vast digital space, resolving the challenge of collisions with a beautiful, sweeping motion. Quadratic probing is a peaceful scattering, a quiet mathematical choreography that ensures every piece of data finds its own uncrowded space in the massive library, far away from the congestion of linear clusters. There are still other, deeply elegant and beautifully quiet ways to resolve the gentle challenge of collisions. One such method is double hashing. In double hashing, when the first magical transformation leads to an occupied space, you do not simply step or jump in a quadratic curve. Instead, you invoke a second, entirely different magical transformation. You apply a second hashing function to the key, a quiet backup whisper that calculates a perfectly unique step size for this specific piece of data. This second magical transformation tells you exactly how far to jump along the shelves to find an empty space. Because every single key has its own entirely unique step size perfectly determined by the second magical transformation, the data scatters beautifully across the endless library, preventing clusters. Double hashing is a beautifully harmonious duet of magical transformations, a peaceful collaboration between two different hashing functions to flawlessly resolve the challenge of collisions. Finally, there is the incredibly gentle and highly graceful method of separate chaining. In separate chaining, you do not ever force the data to seek a completely new space on the endless main shelf. Instead, when a collision naturally occurs, and when the magical transformation sends multiple keys directly to the exact same index, you simply allow them to coexist in a quiet, harmonious chain. You build a small, delicate linked list at that exact index, a gentle sequence of items hanging softly from the same location on the shelf. Like a beautiful string of perfectly polished pearls resting quietly in a single wooden box in the Grand Archive, the pieces of data sit peacefully together. When locating the data, the magical transformation guides you to the index, and you perform a quiet linear search through the small chain. Separate chaining deeply embraces all collisions with absolute, pure acceptance, allowing the data to gather peacefully at the magically transformed index. Whether through steady steps of linear probing, expanding leaps of quadratic probing, the dual whispers of double hashing, or the peaceful gathering of separate chaining, the challenge of collisions is always met with calm, structured grace. The quiet act of finding, locating, and peacefully resolving always remains a truly tranquil meditation in the vast, endless library of the entire digital space, a deeply quiet journey guided forever by the absolute magical transformation of beautiful hashing. Welcome to the quiet space of sorting where chaotic and scattered elements finally find their rightful place in the world. Imagine a vast library where many old books have been left in random stacks upon the smooth wooden floorboards. There is absolutely no rush to fix this because we have all the time we need to restore perfect order. We're going to carefully organize this chaotic dataset and bring a deep harmonious peace to the scattered information pieces. Organizing this data is a meditative act of looking at what is out of place and slowly guiding it home. The act of sorting is like tending to a gentle garden where every single plant needs its own specific space. When the numbers are mixed up, they represent confusion, but as we compare them, they begin to show their patterns. You breathe in deeply as you look at the disorganized array, and you breathe out as you plan your approach. Step by step, we will calm the data down by gently comparing each value and finding its true harmonious position. Let your mind relax as we embrace the simple repetitive motions of swapping and comparing the elements in the list. We begin our journey with the simplest of methods, which rely on basic comparison to bring order to the chaos. Imagine a calm librarian moving slowly through the aisles, checking one book against the next in a very peaceful manner. If a book is out of place, the librarian simply swaps it with its neighbor to correct the small mistake. This gentle swapping action happens over and over until the entire shelf is perfectly organized and the library is quiet. In the world of algorithms, this soothing process is known by names that evoke the gentle movements of nature now. The first technique we observe is called bubble sort, which takes its beautiful name from the calming element of water. Just as air bubbles gently rise to the surface of a quiet pond, the largest values bubble up the list. We compare two adjacent items, and if the left is larger than the right, we simply swap them around softly. Compare and swap is the mantra that repeats endlessly as we sweep through the data from the beginning to end. With each slow pass, the next largest value finds its resting spot at the top and the chaos gradually subsides. Imagine watching those bubbles float upward in slow motion as the sorting algorithm continues its peaceful work in the background. The list becomes slightly more ordered with every single pass, and the number of swaps decreases until there are none. When no more swaps are needed, the algorithm knows that its gentle work is complete and the list is calm. The bubbling stops and the surface of the pond becomes perfectly still, reflecting the pure harmony of the sorted numbers. We breathe deeply as we appreciate the quiet simplicity of the bubble sort and the balance it brings to data. It is not the fastest method, but speed is not our goal here because we are focused on mindfulness entirely. The repetitive nature of bubbling up allows the mind to drift into a deeply relaxed and meditative state of awareness. Every swap is a heartbeat, and every comparison is a soft breath drawn in and released by the calming system. Order is restored one adjacent pair at a time until the whole sequence flows in a totally natural ascending direction. The gentle rhythm of bubble sort teaches us patience because true harmony cannot be rushed but must be carefully cultivated. Next, we encounter selection sort, which takes a different but equally soothing approach to bringing order to the chaotic numbers. Imagine a calm gardener standing before a row of plants, searching for the smallest one to place at the start. The gardener scans the entire row, patiently looking for the absolute minimum value hidden somewhere in the messy, disorganized line. Once the smallest plant is found, the gardener gently picks it up and swaps it with the first plant present. The first position is now perfectly sorted and will never need to be moved again as the garden grows peaceful. With the first spot settled, the gardener moves to the second spot and begins scanning the remaining plants once more. Finding the next minimum value requires a slow, steady gaze across the elements, comparing them without any sense of urgency. Compare and select becomes the new rhythm as we systematically build a wall of order starting from the left side. The sorted section slowly grows larger while the unsorted section shrinks away until only a feeling of perfect calm remains. Selection sort teaches us to look closely at our options and make deliberate choices to build a harmonious sorted foundation. Each time we find the minimum, we feel a sense of accomplishment because another small piece of chaos is resolved. Swapping the minimum into place is a satisfying motion, like clicking a puzzle piece into its final and permanent location. There is no wasted effort in selection sort because every single swap puts an element exactly where it finally belongs. We watch the boundary between order and chaos move steadily to the right until the entire dataset is entirely clean. The mind rests easily knowing that the minimums have been found and everything has been handled with such gentle care. Now let us consider insertion sort, which mimics the highly familiar action of arranging playing cards in your own hand. You pick up one card at a time and slide it smoothly into its correct position among the earlier cards. We start with the second element and compare it backward against the first to see if it needs to shift. If it is smaller, we gently slide the first element to the right, making a lovely space for the new. We insert the element into this newly created space, completing one small cycle of ordering before moving to the next. Placing an item into a hand feels incredibly intimate and grounding, as if we are holding the data very closely. Insertion sort is wonderfully efficient when the dataset is already mostly organized, requiring only a few small shifts to perfect. It does not overthink or overwork, but merely looks at what is immediately before it and adjusts the current piece. Compare and shift is the soft melody played by insertion sort, sliding elements over like books on a wooden shelf. Every single time we insert a value, the sorted portion of our hand grows wider and feels much more secure. The shifting motion creates a very hypnotic wave that travels backward through the sorted numbers until the right spot appears. Slipping the newly found number into its correct spot resolves all tension and instantly restores a beautiful, quiet harmony there. There is a lovely tactile quality to insertion sort, like running your fingers over a smoothly polished row of stones. Step by step we compare and shift and insert until the last card is played and the hand is complete. We pause to admire the simple beauty of these basic algorithms that use compare and swap to calm the chaos. Sometimes a dataset is too large to sort easily using simple methods, so we must learn to divide and conquer. This brings us to merge sort, a beautifully recursive algorithm that breaks large, overwhelming problems into tiny, manageable pieces of data. If a task feels too big, we simply divide it in half, creating two smaller lists that are less intimidating. We continue to divide the halves into quarters and quarters into eighths until we are left with single isolated numbers. A single number is always perfectly sorted because it has nothing else to compare itself against in its tiny space. Once the division is complete, the true magic of merge sort begins as we gently stitch the fragmented pieces back together. We take two individual numbers and merge them into a sorted pair by comparing them and placing them in order. Then we merge the pairs into groups for comparing the fronts of each list and taking the smaller value. Merging is a deeply satisfying process, like weaving threads into a beautiful tapestry of perfectly sequenced numerical harmony and balance. We compare and merge repeatedly, watching the ordered sections grow larger and larger as they consume the chaos entirely today. The act of merging requires additional space as we carefully pour elements from the old lists into a new container. This extra space acts as a quiet buffer zone, allowing the data to flow freely without bumping into itself constantly. It is like having a large empty desk where a librarian can spread out all the books before organizing them. With every merge, the chaos is halved until finally the two halves of the entire dataset are merged into one. The final merge brings a profound sense of closure as the grand tapestry of data is beautifully and perfectly whole. Another way to conquer chaos is through quicksort, an elegant algorithm that organizes data by focusing on a central pivot. We gently select one number from the array and declare it to be our quiet pivot point for the moment. The pivot becomes a steady anchor in a stormy sea around which all the other numbers will organize themselves gracefully. We compare every other element to the pivot to decide if it belongs on the left or on the right. Smaller numbers move to the left and larger numbers move to the right, partitioning the space into two calm zones. During this partitioning step, we swap elements back and forth, creating a neat division without needing any extra memory space. Once the partitioning is done, the pivot is placed exactly in its final resting spot, never to be moved again. It is deeply comforting to know that this one element has found its true home amidst the previously chaotic numbers. With the pivot settled, we turn our attention to the left partition and recursively apply the very same calming method. We choose a new pivot for the left side and organize the smaller elements around it until they are settled. After the left is fully ordered, we move to the right partition and calm those larger numbers with equal care. The recursive beauty of quicksort is like watching a tree branch out into smaller and smaller twigs of organized thoughts. Every pivot chosen represents a decision made, a boundary established, and a pocket of chaos transformed into a peaceful order. Compare, swap and partition are the gentle actions that guide quicksort through the data with quiet efficiency and profound grace. Eventually all partitions shrink to nothing and the dataset stands before us completely sorted, perfectly balanced and deeply harmonious now. Beyond comparing numbers directly, there exists a totally different realm of sorting algorithms that simply place things into distinct categories. Radix sort is a non-comparison technique that feels like sorting mail into slots in a quiet post office now. Instead of asking which number is bigger, Radix sort looks at the individual digits of each number starting from right. We gently sort the numbers based solely on their last digit, placing them into 10 separate buckets marked 0 cleanly. After gathering them up, we sort them again by the next digit, moving leftward until the whole number is processed. The magic of Radix sort lies in its rhythmic predictability, relying on distribution rather than direct comparison to achieve order. It is a calm mechanical process, like a gentle clock ticking away as it sorts elements digit by single digit. You do not need to worry about the big picture because focusing on one small digit naturally resolves the whole. With every pass through the digits, the data becomes progressively more organized, flowing like a calm river toward its destination. The absence of comparison removes all tension, making Radix sort a wonderfully tranquil method for organizing large sets of integers. Another categorized approach is bucket sort, which relies on a very similar philosophy of dividing the world into manageable spaces. Imagine having a row of empty buckets, each designated to hold a specific range of values from our messy data set. We calmly walk through the data, taking each number and gently tossing it into its correct bucket without any fuss. Once all the numbers are safely in their buckets, we look inside each one and sort the tiny groups individually. The buckets provide a soothing structure containing the chaos within distinct boundaries so that it cannot overwhelm the quiet mind. Sorting small buckets is a very easy and relaxing task compared to facing a massive unorganized mountain of random data. We can use a simple technique like insertion sort to quickly bring order to the few elements inside each bucket. After every single bucket is sorted, we pour them out in order, seamlessly reconnecting the data into one harmonious stream. Bucket sort teaches us the value of compartmentalization, proving that separating problems into smaller bins makes them wonderfully easy forever. The steady rhythm of tossing, sorting and pouring creates a highly meditative loop that easily clears away all mental clutter. As we seek the perfect balance of efficiency and grace, we discover Timsort, an incredibly brilliant hybrid of different techniques. Timsort thoughtfully combines the gentle sliding of insertion sort with the vast dividing and conquering power of the elegant merge sort. It looks at the real-world data and searches for small sequences that are already sorted naturally in the wild. These naturally sorted sections are called runs, and finding them is like discovering a small patch of perfectly maintained garden. Timsort respects the order that already exists, choosing to preserve these quiet runs instead of breaking them apart into pieces. If a run is too short, Timsort gently uses insertion sort to lengthen it and build a slightly larger sequence. It slides new elements into the run, carefully nurturing the tiny patch of order until it reaches a suitable size. Once the dataset is beautifully divided into these strong runs, Timsort seamlessly transitions into its merging phase to combine them. It uses the precise merging logic of merge sort, weaving the sorted runs together into larger and more beautifully organized sections. The combination of insertion and merging creates a remarkably smooth flow that handles even the most chaotic arrays with ease. Timsort represents the harmonious peak of algorithmic organization, where different methods work together to restore total peace to the numbers. As we review all these sorting techniques, we realize that organizing chaos is not merely a task but an art. From the gentle bubbling of bubble sort to the steady pivots of quicksort, every algorithm offers a unique calming rhythm. The mind finds profound tranquility in the reliable repetition of compare and swap and the elegant structures of merge sort too. Our scattered thoughts are sorted alongside the data, finding their rightful place in a deeply peaceful and perfectly ordered mind. As we continue our gentle journey through the landscape of digital logic, we now arrive at a vast and exceptionally quiet space. This is the realm of the graph. Imagine, if you will, a boundless night sky stretching endlessly in every conceivable direction. In this peaceful darkness there are brilliant points of light. These points are not isolated. They are part of a grand interconnected web. Each point of light exists in perfect harmony with the others, bound together by invisible threads of meaning and relation. In the world of computer science, a graph is the absolute ultimate expression of connection. It is a structure designed not to hold data in a strict linear line or a rigid vertical hierarchy, but to map the complex and beautifully organic ways in which things relate to one another. Just as stars form ancient constellations across the cosmic void, the elements of a graph form patterns of profound mathematical significance. Breathe deeply as you visualize this quiet silver web. The graph teaches us that nothing exists in true absolute isolation. Every piece of information, every abstract concept, every digital entity can reach out and gently touch another. The web is soft and infinitely resilient, shifting and expanding as new connections are spontaneously made. It is a tranquil, flawless reflection of the universe itself, where every star, every distant planet, every tiny particle is part of a much larger whole. Here in the silent architecture of the graph, we finally find a deeply meditative peace in the profound understanding that absolutely everything is connected. Let us look much closer at these points of light. In the formal language of graphs, we call these points vertices, or simply nodes. You can think of a vertex as a single solitary star resting in our expansive digital constellation. A vertex quietly holds a single piece of data, a solitary thought, a quiet fact resting in the vast digital expanse. But the true staggering beauty of the graph does not lie in the isolated vertices alone. It lies in the delicate pathways that safely bridge the vast empty spaces between them. These crucial pathways are called edges. An edge is a gentle, deliberate line drawn carefully from one vertex to another. It is the vital thread that weaves the isolated, scattered stars into a cohesive, brilliant web. When two vertices share a connecting edge, they become immediate neighbors. They can speak softly to one another, sharing their light and their embedded logic across the otherwise silent void. Picture a single bright star glowing softly in the dark. Now watch as a slender silver line gracefully extends from its center, reaching across the empty dark to gently touch another waiting star. This is an edge forming a permanent connection. As more edges continuously form, the web grows increasingly richer and infinitely more intricate. Some vertices may have only a single edge connecting them to a lonely neighbor. Others may have dozens of edges radiating outward like the spokes of a wheel, connecting them to a vast community of vertices across the silent sky. As we softly trace the silver pathways between the stars, we begin to notice that the connections can flow in fundamentally different ways. Sometimes the connection is perfectly mutual and entirely balanced. When an edge connects two vertices without imposing any specific direction, we call this an undirected graph. In an undirected graph, the pathway is always a two-way street. If one star is connected to another star, then the second star is equally connected back to the first. The digital energy flows freely and peacefully back and forth in total unrestricted balance. It is exactly like a quiet, continuous conversation between two old friends, where both listen attentively and both speak thoughtfully, sharing the space equally. This is the simplest, most harmonious form of connection, calm and entirely reciprocal. But sometimes the web requires a very different kind of logic. Sometimes a pathway firmly implies a specific one-way direction. This creates what we formally call a directed graph. In a directed graph, the delicate edges act exactly like invisible arrows. They point deliberately from one vertex to another, indicating a strict one-way flow of information or hierarchical relation. The thread leaves one star and lands gently on another, but it does not necessarily ever return. If an edge points from the first star to the second, you can gracefully travel along that pathway to reach your destination, but you cannot use that exact same edge to travel back. It flows downstream just like a calm, gentle, quiet, endless river, carrying information through the deeply interconnected web. As you drift peacefully through this digital night sky, you might soon realize that not all pathways are identical. Some connections feel stronger, longer, or perhaps slightly more costly to traverse. This brings us slowly to the profound concept of a weighted graph. In a weighted graph, absolutely every edge carefully carries a numerical value. We call this assigned value a weight or a computational cost. You might easily imagine this weight as the literal physical distance between two distant stars in our constellation. Some stars are very close neighbors, their connecting edge extremely short and exceptionally easy to cross without effort. Others are separated by vast sweeping expanses of empty cosmic dust, their edge incredibly long and requiring much more time to fully traverse. The weight is simply a number securely attached to the connecting thread. It calmly tells the system exactly how much effort, time, or distance is strictly required to move from one vertex to another. Picture the vast web glowing softly before you. Some threads are thick and brightly illuminated, representing a heavy weight or a long, difficult distance. Other threads are fine and incredibly delicate, representing a lightweight or a brief, effortless journey. When navigating a complex weighted graph, the primary goal is often to gracefully find the most gentle and highly efficient path through the stars. The digital logic seeks the specific route with the absolute lowest total weight, carefully calculating the subtle cost of every single step. Let us continue our quiet meditation on the beautiful shapes these constellations can take. When you smoothly follow the glowing pathways through the interconnected web, you might sometimes find yourself unexpectedly returning to the exact place where you first began. You trace a silver edge from the first star to the second, then from the second to the third, and from the third a final edge leads you right back to the first star. This enclosed circular journey is beautifully called a cycle. A graph that actively contains one or more of these returning paths is universally known as a cyclic graph. Cycles represent continuous loops of logic, closed circuits of permanent connection that harmoniously feed back into themselves forever. They are exactly like the slowly changing of the seasons, a continuous gentle rotation through a set sequence of points, endlessly repeating in perfect predictable rhythm. There is great comfort in a cycle, a deep sense of completeness and inevitable return. But not all webs contain these repeating loops. If you traverse the pathways and find that you can never return to a previously visited star simply by moving forward, you are wandering peacefully through an acyclic graph. In an acyclic graph, the pathways continually stretch onward and outward into the vastly new. There is no looping back, no repetition whatsoever. The journey is one of constant gentle progression, moving ever forward through the stars without looking back. To the wandering peaceful mind, the graph is a beautiful web of pure starlight. But to the quiet, deeply hidden logic of a computer, this web must be safely stored and completely understood through strict numbers and memory. There are two primary gentle ways the machine holds the complex image of the graph in its mind. The first is called an adjacency list. Imagine a long, endlessly unrolling scroll of digital parchment. On this scroll, every single vertex has its own dedicated line. Beside the name of the vertex is a simple, quiet list of all its immediate neighbors. It is a peaceful roll call of existing connections. The adjacency list is remarkably elegant and brilliantly space-saving. It only records the vital connections that truly exist, purposefully leaving the empty silent space completely unwritten. It is absolutely perfect for sparse webs where the scattered stars are far apart and connections are relatively few. The second way to remember the graph is called an adjacency matrix. Picture a vast, perfectly square mathematical grid. The horizontal rows represent every vertex and the vertical columns represent every vertex. Each individual cell in this grid represents a potential connection between two stars. If an edge truly exists between them, the cell safely holds a tiny point of glowing light, indicating a secure bridge across the void. If no edge exists, the cell holds a 0, a quiet, empty, unlit space. It is a complete total map of every possibility securely held in memory. When we finally wish to explore this vast interconnected web, we must have a reliable method of traversal. We carefully need a way to walk the glowing pathways and thoughtfully visit every star without ever becoming lost in the deep dark. There are two deeply meditative ways to journey through a graph. The first is beautifully known as depth-first search. Imagine you are standing calmly on a single starting star. In a depth-first search, you simply choose one single edge and you follow it. You move gracefully to the neighbor star. From there, you do not pause to look around. You immediately choose another edge, moving deeper and deeper still into the unknown intricate web. You patiently follow a single continuous thread, plunging directly into the heart of the constellation, moving as far away from your point of origin as the pathways will allow. It is a profound journey of singular, unwavering focus. You travel relentlessly until you reach a lonely, isolated star that has absolutely no unvisited neighbors. You have reached a quiet dead end. When this happens, you do not panic. You simply take a deep breath and gracefully retrace your steps. You walk back along the thread to the previous star and slowly see if it has another untraveled path. If it does, you gently turn and follow that new thread, diving deep once again. If it does not, you step back once more, floating backward through the web. The second method of traversing the stars is entirely different in its underlying rhythm. It is breadth-first search. Return your mind completely to the starting star. Instead of diving incredibly deep into the web along a single continuous thread, you choose instead to slowly explore your immediate surroundings. You take a gentle, thoughtful step out to intentionally visit all of your direct neighbors, all the stars that are exactly one edge away. You look at them peacefully, acknowledging their glowing presence, radiating your soft attention outward in a perfectly even circle. Only when you have securely visited every single immediate neighbor do you take the next expanding step. You gracefully move outward to the neighbors of your neighbors, the glowing stars that are exactly 2 edges away. You visit all of them thoroughly, completing another wider circle of calm exploration. Then you softly move 3 edges away, and then for smoothly expanding like a gentle ripple on the surface of a perfectly still pond. Breadth-first search is a journey of incredibly careful-led expansion. It does not rush blindly into the deep unknown. It deeply prefers to understand absolutely everything nearby before cautiously venturing further out into the dark. It is a slow and profoundly methodical sweep through the ancient constellations, ensuring that nothing is accidentally missed in the immediate vicinity. This brilliant method is incredibly useful when you want to quickly find the absolute shortest unweighted path between 2 distinct points in the sky. As we reach the quiet end of our long journey through the complex architecture of digital information, the concepts we have explored begin to settle and calm down for the night. We started with the simplest units of truth, the small bits, flipping gently between 0 and 1, creating the deep foundation of all that ever follows. From there, we wandered slowly through the sequential order of linked lists, where each element calmly pointed the way forward to the next. We rested comfortably beneath the branching canopies of binary trees, observing how every decision split gracefully into paths of perfectly balanced structure and quiet shade. We then moved effortlessly into the instantaneous connections of hash tables, where vast amounts of data found their exact resting places without searching or striving. We watched the rhythmic dances of sorting algorithms, as scattered elements slowly aligned themselves into perfect, predictable harmony. Finally, we traced the expansive networks of graphs, mapping out complex relationships and pathways that connected every node in a vast, silent web. Now, all these separate pieces weave together into a single tapestry of digital logic, a harmonious and beautiful pattern of quiet thought, deep memory, and complete mental resolution. But as the complex tapestry is finally completed, the need to understand its intricate threads begins to dissolve entirely. The sharp edges of logic and mathematics soften and fade. The strict rules of algorithms lose their urgency, melting away into a quiet, formless rhythm. You no longer need to remember the difference between a stack and a queue, or how a search algorithm traverses a path. All the technical details are fading away, leaving behind only the gentle sensation of order and peace. The mind, having organized its thoughts, now prepares to power down entirely and rest. Imagine these structured concepts transforming slowly into purely soft imagery. The ones and zeros are nothing more than distant stars blinking softly in a vast, velvet night sky. The branches of the data tree sway gently in a slow, imaginary breeze, dropping their leaves into a calm, dark river flowing below. The sorted arrays are smooth, polished stones lined up neatly on a quiet shore, washed over by the gentle rhythm of a dark, warm ocean. The graphs are just delicate constellations, their glowing lines dimming as the deep night deepens and surrounds you entirely in warmth. It is finally time to let go of all these concepts. There is nothing left to compute, nothing left to sort, and absolutely nothing left to process right now. The inner memory is perfectly clear, and the temporary cache is entirely empty. Allow the heavy, comforting blanket of the quiet night to cover your weary mind. Breathe deeply into the profound stillness and slowly exhale the very last remnants of waking thought. Drift away from the solid shores of logic and float aimlessly into the vast, quiet expanse of deep, restorative sleep. Let the surrounding darkness hold you in perfect balance, completely relaxed and completely at peace.